Today, we're heading out into the cosmic dark. We're going looking for the trillions, yes, trillions, of unseen worlds that are just wandering through our galaxy completely untethered to any star. We've all seen the movies, right? Some giant asteroid is hurtling towards Earth and it's threatening total Armageddon. But what if the danger wasn't about a big explosion, but something different? Could an impact be so powerful that it literally knocks our entire planet out of orbit, sending us rogue into the freezing cold of space? Well, it turns out the science is pretty clear on this one. And the answer is no way. Think of it like this. The energy holding the Earth together, its gravitational binding energy, that's like a really strong glue. But the energy that keeps us locked in orbit around the sun, that's a ridiculously powerful engine. For an asteroid to even nudge our orbit, it would need to hit with so much force that it would completely overcome that glue first. So the bottom line is, any impact strong enough to change our path would absolutely shatter our planet into a million pieces long before it could send us flying. Okay, so we can relax. An asteroid isn't going to send us careening into the void. But, this whole idea brings up a much more fascinating question. The real story here isn't about Earth getting knocked out of place. It's about the cosmic wanderers that are already out there, roaming the galaxy all by themselves. And that brings us to our first section, the planet wanderers. So what exactly are we talking about here? A rogue planet is basically a world that isn't gravitationally tied to any star. It's just out there, adrift. You can think of it as a kind of orphan world floating in that vast, dark emptiness between solar systems. And just how many of these lonely worlds are out there? Well, the scale it's almost impossible to wrap your head around. Astronomers think there could be billions, maybe even trillions of them right here in our own Milky Way. That could mean there are actually more wandering planets in our galaxy than there are stars. Just let that sink in for a second. Of course, a number that's staggering leads to a really big question, which brings us to Section 2, finding invisible worlds. I mean, seriously, think about it. These planets don't have a star to light them up. They're cold, they're dark, and they're tiny compared to the sheer blackness of space. So how on earth do you find one? It is probably one of the biggest needle-in-a-haystack problems in all of modern astronomy. Well, to solve this incredible puzzle, astronomers have come up with two really clever techniques, something called gravitational microlensing, and the other is direct imaging. Let's break down how these actually work. Microlensing it's genius. It basically uses gravity itself as a detection tool. So Einstein's theory of relativity tells us that any object with mass, even a totally dark planet, warps the space around it. When a rogue planet happens to pass perfectly in front of a distant star from our perspective, its gravity acts like a cosmic magnifying glass. It bends the starlight and for a brief moment makes that star appear brighter to us. And here's the really cool part. How long that brightening lasts tells scientists the mass of the invisible object that passed in front of it. And this isn't just theory. This method really works. Back in 2020, it led to this huge discovery. The first ever candidate for a rogue planet with a mass similar to Earth's. It was the shortest microlensing event they'd ever seen, and it proved just how powerful this kind of cosmic detective work can be. Now, the other method, direct imaging, is a little more straightforward. You can think of it like regular space photography, but for things that are incredibly faint. Instead of looking for a weird gravity effect, telescopes are trying to spot the faint, leftover heat that's being given off by really big, really young rogue planets. These are the ones that are still glowing from when they first formed, and you're most likely to find them in those stellar nurseries where they were born. So, we know they're out there, and we have these amazing ways to find them. But that just begs the next question. Where do they come from in the first place? That brings us to Section 3, a rogue's origin story. It seems like there are two main origin stories for these wanderers. The question is, were they born this way or were they banished? In one scenario, a rogue planet forms all by itself, kind of like a star does, from a collapsing cloud of gas. It just never gets big enough to actually ignite and start fusion. In the other, much more dramatic scenario, it forms as a perfectly normal planet inside a solar system, only to get violently kicked out by the chaotic gravitational pull of its planetary sibling. Now, that ejected planet theory leads to some pretty interesting predictions. Computer simulations show that most of these cosmic orphans would probably be pretty small, less massive than Earth. A star like our sun is expected to eject a whole bunch of smaller stuff over its lifetime. But kicking out a true giant, like Jupiter, that seems to be a very, very rare event. Okay, so there are trillions of these wandering worlds out there. Some were born alone, some were kicked out of their homes. Let's bring this all the way back to our original question in our final section, what it means for us.
So, should we be worried? Is one of these rogue planets going to come barreling through our solar system? The odds are, fittingly, astronomical. Current estimates put the chance of a rogue planet posing any kind of direct threat to Earth at about 1 in a trillion. So yeah, you can definitely sleep soundly tonight.
And even in that incredibly unlikely event that one did swing by for a visit, simulations show it probably wouldn't stick around. It might get caught in a wobbly temporary orbit for a little while, but the huge gravitational tug from our own giant planets, especially Jupiter, would most likely act like a giant cosmic slingshot and just flink it right back out into deep space, where it came from. And really, this gets to the core takeaway of the whole thing. The number of rogue planets in our galaxy is just immense, trillions potentially. But the actual direct threat that any single one of them poses to us, it's vanishingly small. It's a good reminder that we live in a universe that is mostly filled with wonders, not one where danger is lurking around every corner. And that leaves you with one last kind of mind-blowing thought. We've only just started finding these hidden worlds. With trillions of planets wandering the galaxy, each one a unique place with its own history, its own story. What else is out there, just waiting to be discovered in the dark?